Welcome back, everyone. In this video, we're going to be introducing loops. And we've already seen an example of loops being used in our pseudocode video. If you haven't watched that yet, I suggest you check it out so that you can follow along easily. However, I think it'll be evident once you see loops in action just how useful that they can be, if that's not already apparent. So loops are a fundamental concept in programming. And loops are going to give us the ability to perform some action over and over again, either a finite number of times that we can determine, or even infinite loops that'll keep running forever. In our pseudocode example, we saw the use of loops when we kept searching the page one by one until we found the word that we were looking for. But now let's see how we can do this in C. And frankly, the syntax for writing loops in C, as well as many other languages, isn't the simplest. However, with some practice and repetition, these will become second nature over time. And we're going to start with the simplest example that I can think of, which would be just to print something to the screen over and over again. To do this, we're going to be using what's called a while loop. And again, the syntax might look intimidating at first, but we'll go character by character explaining everything that's going on here. To use a while loop in C, we're first going to need a variable that we can store an integer in that's just going to keep track of how many times we're going to run this loop. And we already know how to do this. We just define a variable of type int, and we'll name this variable counter, for example. And to start, we're going to assign the value 0. Why? Well, because in programming, we generally start counting at 0. And this will become more and more apparent why when we see more examples. We'll end this with a semicolon. And now to create a while loop, we'll use this while keyword, followed by a space and open and close parentheses. Then on a new line, we're going to do open and close curly brackets. And this syntax so far is similar to our if statements, if you remember. Now inside these parentheses, we're going to be checking some condition. For this example, let's say that we just want to print something 3 times. And so in these parentheses, I'm going to put counter is less than 3. And this can be read as while the counter variable is less than 3, we want whatever code we write inside these curly braces to run. And what did we want to do? Well, each time we looped, let's just print out hello world, for example. And we're not quite done yet. Inside these curly braces, we also have to increase our counter variable. And to do this, it might look a little strange, but we can say counter plus 1 and assign that value back to the counter variable. And remember, this single equals does not mean equality. We're not saying here that the counter is equal to the counter plus 1. That wouldn't make any sense. We're saying here to take the counter variable, which is 0, and add 1 to it, and then store that new value into the variable called counter. So if counter is 0, when the compiler gets to this line, it'll add 1 to 0 and give us 1, and then store 1 into the counter variable, essentially incrementing the counter variable. And this is such a common operation to do in programming, like just increasing a value by 1. So we have shorthand notation for this. It's called syntactic sugar, so to speak. And under the hood, the same thing is happening. We're just using a different syntax. So we could do the same thing by using counter plus equals 1, just like this. And this would have the same effect. And probably the most common and simplest way of doing this, of just incrementing a variable, is by using the increment operator that we briefly saw in the last video. So it turns out we can achieve the same result by using counter plus plus. And this will increment our counter variable by 1 each time this loop runs. Now let's take a step back and explain this from the beginning, because I know this can be a little confusing, especially if you're new to programming. So on this first line, we're creating a variable called counter and assigning it the value 0, which is an integer. Then, with this keyword while, we're inducing a loop. And when the compiler gets to this line in our code, it's going to evaluate this expression. And this expression in the parentheses is to check, is the counter less than 3? Well, what is the counter? Currently, the counter is 0. So, is 0 less than 3? Well, yes, it is. So this expression is going to evaluate to true. And if this evaluates to true, the code in these curly brackets is going to run. And what are we doing down here? Well, we're going to print out hello world, and then we're going to increment our counter variable. So after this line runs, the counter variable is now 1. And this keyword while is like a hint to the compiler. And it knows that if this expression evaluates to true, then it should come back and check it again after it executes the code in the curly brackets. And so then it would just check again, but this time with the incremented variable. So we check again, is the counter less than 3? Well, the counter is 1 this time, because on the last iteration, we incremented it from 0 to 1. So is 1 less than 3? Yes, of course it is. So this evaluates to true, and we again run the code down here, and then counter is going to be 2. And now since we got true last time, we're going to check this again. And is 2 less than 3? Well, yes, it is. So again, we run this code, we'll print hello world, and increment the counter. And now ask this question a final time. Is 3 less than 3? No, it's not. So this is going to evaluate to false, and the compiler knows that if this expression evaluates to false, then we do not run the code in the curly braces. And we also will not recheck this condition anymore, essentially breaking out of this loop and continuing with the rest of our program. So that was a mouthful, but now let's jump into our virtual machine and actually code this up and see how this works in action. Alright, so I'll open up my terminal and I'll change directory in my tutorials directory and use code dot to open up VS Code right here. And now let me create a new file. I'll call this loop.c. And in here we'll do our normal boilerplate, hash include stdio.h int main void, and open and close curly brackets with return 0 down here. And first thing I'll do is create a variable called counter of type int, and I'll assign it the value of 0. Then I'll use this keyword while, and I want this loop to keep running while the counter variable is less than 3. So I can say counter less than 3, and then I'll open up my other set of curly braces. Now in these curly brackets, I'm going to first print out this counter variable just so you can see it being incremented. But I'm not going to add a new line because I want this to be on the same line. So I can do printf, and then I can do my placeholder of %i, and we want to pass in the counter variable. Next, we want to print out hello world, followed by a new line. And lastly, we want to update our counter variable. So I can say counter is equal to counter plus 1. Or if I want to be a little more succinct, I can use our syntactic sugar of counter plus equals 1. Or if I want to be even more succinct, I can use counter plus plus. And these are all going to have the same effect. And this counter plus plus is usually preferred if for no other reason than it's less characters to type. And now I'm going to save this. I'm going to slide this over just so we can see our terminal and our code. And let's go ahead and compile this. I'll say gcc-o loop and loop.c. We see that we get no errors. Let's go ahead and run this. /loop. And we can see on the very first pass, counter was equal to 0, and we print out hello world. Then we increment our counter variable. And on this next pass, the counter variable is equal to 1, and we're again printing out hello world. Then finally, the counter variable is going to be equal to 2, and we'll print out hello world. But over here, after that counter variable gets incremented to 3, this question, is counter less than 3? Well, is 3 less than 3? No, it's not. So it's false, and we'll essentially exit this loop. Now, I hope you understand this syntax. I know it was confusing, but if you get some practice and just kind of think through it step by step like we did, this is going to become much easier over time. But one thing that I mentioned earlier was that we can induce an infinite loop. And after that explanation, you might now be able to think how we could do that. We know that when the compiler sees this keyword while, it's going to check the condition. And if that condition is true, it's going to run the code and then recheck the condition. So how could we now coerce this to keep checking the condition forever? Well, we could supply a statement that would always evaluate to true. For example, here we're checking if the counter is less than 3. But what if instead we checked if this counter is equal to 0, which it already is. And then down here in our loop, we can delete this line so we never increment our counter. And this would have the effect of checking, is this counter equal to 0? And of course that's true. So the code would run, we'll print hello world, and then we'll check the condition again, and it's true. And if counter never changes, then you can see how this would just keep looping forever. And we can see this in action. I'll save this, and I'll come back here to my terminal, we'll compile this, and then we'll run this, and we can see that it's just going to keep printing hello world over and over and over again, forever. And we can see our counter variable is equal to 0, and it's just going to keep printing. And it turns out that you can press Control-C on your keyboard to essentially kill any program that's running in the terminal. And this is how you would get this to stop if you found yourself stuck in an infinite loop accidentally. But this is just to show you how we can induce an infinite loop. But frankly, this is kind of stupid. And generally, if we want to induce an infinite loop, instead of asking this question here, we can literally use the value true. However, if you want to use this keyword, there's a header file that you have to include that's going to define the keywords true and false. And that header file is called standard bool, or std bool. So I'll come up here, include std bool.h, and I'll save this. Then if we come back here and we recompile, rerun, we can see it still works just the same. So this is one way that we could implement a loop in C. And there are actually a few different ways that we can induce loops in C. Again, what we just saw is often called a while loop. However, we can also use what's called a for loop. And again, the syntax for this might feel strange and unfamiliar, but we'll walk through this step by step, just like in our last example, so that you can get a feel for these loops as well. I'll come back to my program and I'm going to delete this whole thing. To induce a for loop, we first use this keyword for, followed by a space and open and close parentheses. And then on a new line, we can do our open and close curly brackets, just like we would a while loop. Now for loops are going to work just like while loops, but they're going to let us keep our code a little more succinct. Instead of declaring our counter variable outside of our loop, like in the last example, with for loops, we can initialize it right here in our parentheses. So I can say int counter is equal to 0. And I'll end this with a semicolon. And now I'll put my condition that I want to check. So just like our last example, I'll use counter less than 3. But this time I'll end this with a semicolon as well. And finally, I'll update my counter variable. So I can say counter plus plus. And although this looks strange, it's going to work just like our while loop. We'll put the same thing down here. But first I want to print out this counter variable so we can see it. And then I'll print hello world. So I can say printf %i and pass in counter. And then I'll print hello world, followed by a new line. I could type. And the way this is going to work is that the compiler will get to this line and it'll see this keyword for. It'll then know to declare this counter variable to 0 and then ask this question: is the counter variable less than 3? The answer is yes, so this is true, and it'll run this code down in these curly brackets. And then finally, it's going to come back up here and increment the variable. Then it's going to recheck this condition. Counter is now 1, so is 1 less than 3? Yes, it is. So we'll run the code, we'll increment the variable, and we'll recheck the condition. Notice though that even though we're declaring this variable inside the parentheses, the compiler is smart enough to know that it shouldn't do this again. Like, it wouldn't make much sense for it to reassign the value 0 to the counter each time. So each iteration, so to speak, or pass of the loop, it's just going to check the condition, and then it's going to update the variable. And when this condition is finally false, it'll then break out of this loop. And since we have no more code down here, our program will just exit. And although it goes against everything I've said about using descriptive variable names, the convention in C and in other languages is to use the variable name I here as our counter variable. So sometimes you'll see int I is equal to 0, I is less than 3, I plus plus, and then we'll pass in I here as our counter variable. And this is achieving the same result, just using I instead of counter. I used the word counter in this example simply because it makes this easier to understand, and I'm a fan of descriptive variable names because it makes code easier to read. And you can do this either way. I prefer the counter variable name. However, if you're reading other people's code, you'll often come across something like this. And the same is usually true for while loops. You'll see the counter variable named I. Just short for integer, really. So now we've seen two different ways that we can induce loops in our code. These examples we went over didn't really do anything interesting. They just printed the same thing over and over again. But now that we have this fundamental building block in our tool belt, we can start to see how we could use this construct to perform much more complex operations once we get a little more experienced. There are other ways as well that we could induce loops in C. One spoiler would be something called a do-while loop, which lets us do something at least once before we check our condition. But we'll see examples of do-while loops in later videos. I really hope you're enjoying my videos and getting some value out of them. If you have any questions about these while loops, for loops, or any questions in general, please leave them in this comment section. I'll respond as soon as possible. If you did enjoy, make sure you hit that like button so that I know you want to see more content like this in the future. In the next video, we're going to play around with these loops a little more and put all of the concepts that we have learned thus far together. We'll see how we can nest these loops inside one another, and we'll talk about the differences between good code and bad code, and what we can do to ensure that we're writing good code by following best practices and conventions. So thank you all so much for your support, and I hope to catch you in the next video.